Okay, so the next problem is molecular shape and polarity, and this time we have a chlorine with 3 fluorine attached to it. So chlorine is right here, and fluorine is right here, is all 7 in halogen. And because of the size, the chlorine is only 1, they sit in the center, and the fluorine is going to form the bond. So chlorine, the first thing you need to think about is 7 valence shell electrons, and this 7 valence shell electron will form the bonding with 3 fluorine in the neighborhood. So 3 electrons are being used for forming bonds, right? So 3 bonds is as in a form of fluorine with this. Okay? Fluorine has a 7, right? Fluorine has a 7, and they need 1 electron to form the bond. So they are using, among 7 electrons they have, they're using 3 of them. And then what's there left over now? You have 4 electrons left over, and this one will be paired up. 1, 2, 1 lone pair, 1, 2, second lone pair. So you have 2 lone pairs. And how many bonds? You have 3 bonds. So this is one of the interesting example where electron group, which is a lone pair and the bonds. How many you have? Lone pairs? You got 2. You got 3 bonds. So therefore 5 Eg, and 5 Eg means you have a triangle, and there is a 1 at the top, and there is a 1 at the bottom, right? So this is what is called there's a 1, 2, 3, 4, 5, and this is where your central atom located. This is we call the geometry called trigonal, because it's a triangle, but they are 2 pyramidal structure. Right? So bi means 2, right? There are 2 pyramidal structures up and down based on this. Okay, one is up there, the other one is at the bottom, right? So this is a triangle with a pyramid upside down, and both are there. So that's the geometry. But now we need to figure out, so once again, I'm going to draw the triangle. So triangle looks like this. This is a triangle, and there is a bond up, and then there is a bond up and down. So this is where things looks like that. And then where do I put lone pairs? Here's the lone pairs. I have 2 lone pairs, right? Lone pairs. And so this one goes to equatorial, okay, at the side of this plane. So they're going to locate it here, and the lecture should explain that why they prefer not an axial, okay, not axial, but equatorial position, and to minimize the repulsion. That's what's the reason we call Vespers theory, to minimize the electron pair repulsion, and this is a better because this is a 190 instead of 190 instead of 90. This is a 120 degree angle differences, so they are more stable. So having said that, chlorine goes in the center, and we are going to look at F, and you're going to look F, and this is a look F. So then you're going to, just for the shape wise, we are not going to look at the lone pairs. So you can see that chlorine and the fluorine is up, and this one is at there, right? And then there are 2 lone pairs forming a sort of the very invisible plane, right, on here, but we are not going to count it. So going back to the shape argument, this one is essentially called T shape. Because of the T shape, it is an asymmetric, and so therefore it is a polar molecule. Okay, so that's the answer. So this is a polar. This molecule, CCl4, is polar. ClF3 is a polar. Thank you for your attention.